signals to a couple of different coils in the stepper motor. When one is activated, it causes it to step ahead one position. Then you do the other one, it steps another one, so on and so forth. How quickly you give it those step commands determines how fast it moves. Now, you can stop the servo motor and it'll stay where it's put. The problem is you do not necessarily know where it is. It's got no feedback on position. You can arrange in the circuit some sort of reference point and count either way from there as you step, but there's no inherent positional information. It's very precise in its positioning at stops. It's one of the reasons Doug and Jason are using it on the turntable upstairs, because you can step so many points and then stop it right in line with the roundhouse track. Again, you got to know where you started from to get where you're going, right, Doug?
Yeah, it's all relative.
Yeah. So now a servo motor is a little bit different. A servo motor, or servo for ease of use, doesn't have continuous rotational possibilities. Usually it's got a positional capability of half a turn, 180 degrees. But within that 180 degrees, it can be positioned quite accurately without any reference points, because the reference point is built into the servo. When you send a command to the servo to go to one point, it'll go there because it knows where it is now and where it has to go to. So, now, both the servo and the stepper motors are a type of equipment that you don't just put a voltage on them and expect them to do anything. Stepper motor has two coils that alternately step the motor around. Servo motor's got three lines: power supply, ground, and a signal line. The signal line is basically pulsed to give the control electronics in the servo information where it wants to put the thing. Now it knows where it is basically because the output shaft is connected to a potentiometer, and as the shaft turns, the wiper on the potentiometer turns and the voltage changes to let the control circuitry know where the arm is. The pulse is basically a repeating pulse, and how long it's active within the pulse period is basically an indicator of where you want the arm to be positioned. In other words, a very short pulse will put the arm very near the zero position. Stepping it up, as the pulse gets wider, the arm goes further before it stabilizes. And then when you go full up, it's pretty much as far as it'll go. Now, if I sound confused a little bit on this, I'm still learning myself, so if you've got any questions, I'll try to answer them, but I can't make any promises. But how are we doing so far? Have I buffaloed everybody?
No.
No.
I know everything you said is correct.
Well, that's good. You've had experience with this numerical controlled machines, right?
Yeah.
Yeah. That's a good application for servos. In the hobby industry where we are interested, servos are usually involved in model airplanes where they control the flight surfaces. Race cars, they control the steering and other things like that. Robots, arm positioning and things like that. You were about to say something, Mel?
Like I say, the RCs actually control a
carburetor with them. They actually control speed with
That's
it.
another point. It's similar to the other control surfaces.
Right.
Same with the fired steam engines. You can get RC systems to run the throttle and
Yep.
the valve gear.
Any place where you need a controlled motion, the servo is quite handy for doing that.
Here's some of the things that you'd use in model railroading.
Any angular stop control, but using the different radius hole, you select that with the distance that you want for your swing.
Yeah.
So it
Now-
works a lot like your tortoise switch machine, where it just bottoms out at the end and stays there until
Well, there's no necessity to go to the extremes on that either, because you can program it to operate over a small portion of its available arc.
But then it doesn't have the feedback control. You're not
Yes, it does,
Yes,
It does?
because it's
That's
continuous.
what the potentiometer does.
The potentiometer in
I
there,
had the pot in there.
yeah, the part's in there, and it's keeping continuous track of where that arm is. Now, if you only wanted to run the arm 20 degrees, something like that, by setting in the proper data to the controller, you could have it go from 20 degrees to 40 degrees or something like that.
Then why do they have the control for the stops through software and also have a radius control to give you basically a gain control for the motion? You wouldn't need both.
You're getting a little bit beyond me right now with that, but
Okay. Because if you wanted, let's say, a 2 mm distance traveled, you could put it in the, let's say, second hole and say go so many degrees, or you could put it in the fourth hole and say go half as many degrees. So they're giving you two ways to make the same change.
yeah, that's something that you'd hash out when you set things up. It's not something that you'd particularly be using alternately. At least as far as I see things going. But, oh, there it is, way down there, okay. But,
Oh, you want it back?
don't worry, you're not getting out with
They
it.
get frisked on the way out, don't worry about it.
Don't take it personal.
Well, you can, but it won't do you any good. That's right.
As you progress, you
Yeah.
move it out.
So it's a way for you to change the controls without going to the program.
Actually, the programming isn't all that difficult.
But what fooled me is if I see the different holes there for a different throw, you don't need to program it. And if you can get something like the limit switches that they use on the tortoises, it can be up and down.
Yeah, but why use that when it's already built in?
You can have
By
5 or
programming.
6 different positions in the stroke, have it
Yeah.
automatically stop. And then to help give you the range you need, you've got the different lengths from the arm to help you
Yeah.
control the amount of movement during that.
Say you were using it to operate a semaphore.
Yeah.
Semaphore can have either 2 or 3 positions depending upon the type of signal it represents.
Right.
And you could do that with this very easily just by programming the proper angular displacement
places as
for
opposed
each
to
of the
having to-
aspects.
Right. The other way, you'd have to have 2 individual
Yeah.
controls.
Yeah.
But it'd be simpler to set up from the point of view of you don't have to get to a computer and tell it where the stops are. Some people like one versus the other.
Well, that's, if you wanted to do it that way, that's fine. Whatever floats your boat or sinks your barge or whatever.
That's the way the egg rolls.
Yeah, so, but anyway, I have it, a little demo program set up on the Arduino here.
Just a quick check on eBay, there were, you can get 5 sets of those servos with linkages and all that stuff for $16 shipped.
That's cheap.
There's a program in here, it's a demo program from the starter kit, which drives it to a number of different positions, and in some cases, steps it at 2-degree increments to slow it down.
So the speed is governed by the software as well?
Yeah,
Now, the little mechanism you have there, is that the actual controlling it?
which mechanism?
You have all the white wires on it? Is
Yeah.
that the way
This
you
is
set
what-
up what you want it to do?
This is what's controlling it. The program to operate the thing is in here. This is just interconnects.
Okay.
There's only one wire coming out of the microcontroller to control this. There's enough capability there that the program could be set up to control at least 8 of them.
From that little board?
Yep.
I mean, that was my question. If you don't have a computer in your setup, how are you gonna run these things? I mean, we know how our other switch machines work. They're basically just a switch. But you obviously need a mini computer that run this little level.
Yeah. Now, to program it, the easiest way to program, in fact, actually the only reliable way to program it right now is using Arduino software on the PC and just downloading it. And once you've got it set up and checked, download it and try it. But once you've downloaded it, the computer is no longer necessary per se. In some cases, you use the USB cable to provide power to the board, but that's not the only way you can do it. You can, as I have here, it's got a regular barrel type connector. I got it running off a 9-volt battery right now.
So it's set up for 5 volts or 9 volts?
Pardon?
Is it set up to run as,
It's got a onboard regulator to bring it down to 5 volts. And somewhere in there, it also pumps out some 3.3 volts.
And there's room in there for inputs to tell it to start a cycle on a particular motor.
Mhm.
Yeah.
How complicated is the language that you would program it at?
Right now, I'm still scratching the surface on it. What I've seen so far looks very much like C++. They have a lot of routines already canned, and you just pull them down and include them. So there's not a whole lot of debugging. This here took about 5 minutes to get it out of the library and onto the board. The last 2 sheets on that, I think, are the actual program that this is running. I'm sorry, last 2 sheets. Now, everything that starts with a // is a comment.
Yep.
So Jack, what it's doing now, is that going, like you said, every 2 degrees, so it slows it versus that one that spins right through?
Yeah, that's a 1 degree. That's a no stops.
90.
That's a 2 degree. Now between each of those steps, there's a pause
Right.
and that's basically what slows it down.
So if you were gonna like use a crossing gate, you would want it to move constantly, like so. You don't want it to shoot quick.
Right.
So you would put like 2-3 second increments or,
Well, it wouldn't,
degrees or
probably,
whatever.
Probably wouldn't be that long,
Yeah.
but yes.
but you would degree it so it would move it
You
slowly.
step it and delay between each step, and if your steps are small enough and the delays aren't that long, it almost looks like it's continuous motion.
Well, that's what I see on the one there where, like, not that, but like something like that. See, now that one would be something like a crossing gate
Yeah.
would be used.
Those are nanoseconds.
No, you can slow that right down to where it's just a crawl.
Yeah,
Now, how would that be done? Is that lowering the power or putting in more sections to like
putting in more
stop?
steps or increasing the
Doing
delays.
1
or
degree
both.
with a certain period of
Yeah.
time,
Okay.
in nanoseconds probably, in between each
Right.
one,
Okay.
to slow down to get there.
Yeah.
How would this be used on a switch?
On a switch, you'd have to program it for the right swing to throw the switch. You'd also have to have controls on the board to tell it when to switch it, straight through, curved track. And
Like right now, we've got a switch machine with a decoder.
yeah,
Would you still need a switch machine and a decoder with this?
right now, the decoder part of it, I don't have an answer to. Doug has given me some clues, and I'll follow up on them, but
You could get something like digital output. There's a Tower 64 controller that just gives you a high or low TTL output.
yeah.
And from there you could have your board interface to that.
This board will accept any number of inputs, I presume?
I think it's got about 13 or 14 input lines.
And those can be,
Those digital input lines, there's a
Right.
few more analog input lines as well.
those could be programmed,
Yes,
okay?
yeah,
An aux box could control this.
yeah.
The Xbox
Jack-
also Digitrax aware or DCC.
DCC programmable, yeah.
Another interesting thing you could do with that is you could have photocells in the module, and when a train comes up and trips a photocell, it could tell it to align all the tracks for it to head out to the main line.
You mean like when it's ready to go across the gauntlet track, it could align the switches?
So,
Someone has written, or a group of people have written the LocoNet library, which gives you the
Open
interface
source?
to LocoNet.
Yeah.
Yeah. And so they built it to go into the Arduino.
Yeah.
I haven't played with it. I mentioned it to Jack. So in theory, I think this has been done. You can use the LocoNet library, which they have made open source, pull that in, build that into your application, and effectively you can make a stationary decoder to control whatever you want. In this case here, control a servo, which then maybe 2, 3, 4, I don't know how much, Jack mentioned 8, but it gets into all the available input outputs that this particular board has.
That's not the only thing as well. The expense of the controller board is relatively low. They're available on the web in the area of $20 a piece, which is nothing.
That's cheap.
That is. For the capability, I'm amazed.
The controls up to eight different
Yeah,
functions?
that's too simplistic.
6 to 8?
That's too simplistic, Mel, but
Sorry.
there's an awful lot of capability in there. Of course, we're barely scratching the surface here with this particular application, but the thing is, you could have one of these boards doing one thing, another one down the road a ways doing something completely different. And like I say, they're all basically autonomous.
Now, I think I saw in MicroHeart, they had a system with a servo like this. But they gave 3 different servos. Now, I'll be honest with you, I didn't have any idea. What would be the difference between this and, say, a larger servo or smaller, would be power?
Primarily, well, power would be one. There's typically what I've seen so far is the standard servos, miniature servos, and micro servos. This is a micro. The difference between them is power consumption for one, and their capability moving something. It's usually shown in gram centimeters or something like that. I don't happen to have it for that particular one here, but the larger ones are more powerful. They'll move a heavier load, whatever.
and the price will probably vary, the increments in which you can program too.
That, from what I've known so far, don't quote me on it, but their capabilities in terms of angular motion are pretty much alike.
The
Half a turn.
incremental stepping.
Incremental is largely a position, a capability of the signal coming in. because as far as I know, internal there, it's analog.
Okay,
So it would depend upon the resolution of the plot,
yeah.
things of that nature. Just as a benchmark, the micro servo like that, I was down at Radio Shack today looking at some of the stuff they had there. I think it was $11.95 or $12.95 for the micro and $14.95 for the standard size. Don't buy at that price.
Don't ask me what it is.
That's the program that's running.
C++ yet, John?
Advanced ballasting.
Basically, what I just read there is this whole thing about managing the pulse width that you mentioned and all that stuff. The nice thing about it, that's all done for you in the underlying software, and all you have to do in your scripting is say, go to 1 degree, go to 10 degrees, or whatever degree you want.
There's an include file for
Yeah.
all the servo commands. You bring that in, and that makes all the servo commands available to me.
It's more like data-driven programming. Basically, you're explicitly telling it the data that you want.
Yeah, and then if you want it to slowly move, you can say, move to 1 degree, wait so many milliseconds, go to 2 degrees, go to 3, 4, 5, and you'd increment it up and you'd get it to slowly sweep out whatever degrees you wanted. And then you could go backwards and you can get it to do all this dancing around, whatever you want it to do, basically.
But basically, you only have a swing of 180 degrees.
On a servo, that's typical.
Yeah.
And in fact, depending upon what you were driving, you might not even want to use the entire 180 degrees because at the ends, it would become awkward for the linkage.
Right.
If you use, say, the middle 90 degrees plus or minus 45, so you get from 45 to 135 where you're out at the one end with a pretty much linear push. It's basically the same reason you apply handbrakes on a streetcar at 90 degrees, you know, at 9 o'clock, so that you've got the good leverage. So,
Now, you could actually, I'm thinking of an application for this which would not use a solid wire. And I think most of us use solid wire, for instance, on switch machines. I'm thinking of, I think you and I talked about
yeah,
the
for your
fuel
fuel
loader.
loader, yeah.
Right, and I've got a bucket that I want to close and open, and I was thinking that perhaps what I would do is do that with a small, well, actually fishing line. So I would actually have a push, I mean a pull situation. So I would close and open, you know, force it this way. And so this is gonna work in both directions. It doesn't care the dang which way you're going.
Yeah, and they have some, most of these come with a couple of different attachments for connecting the loads.
John, you wanna move his coffee, please?
Get the servo to do it.
Well, here, read that up in mine. Yeah, you know, let the servo motor do it. Let the servo motor do it. Are you serious? I'm serious. I can't see these are 2 cups of coffee. Thank you. Is that better?
I didn't know you wanted to. Sorry about that.
You liked watching that? Go back and forth.
So is that the starter kit that you picked up, Jeff?
Yeah, it is. Yeah, this was on the big bookseller on the web, Amazon. It's amazing the stuff they sell.
So you didn't buy it from Spark Fund directly?
No, I didn't.
Is it cheaper at Amazon than direct, or you didn't want?
That was $49.95, but I used my Discover Card bonus points. It didn't cost me a cent.
Oh, that's perfect.
Should have gotten 2.
The price was right, Jack?
Pardon?
The price was right.
And why did you bring them out, just out of curiosity?
I wasn't sure whether I'd be using the computer or not. That's over on the table there.
Oh, okay.
No.
All right.
So what do you envision and what we will use the servos for upstairs besides, I mean, crossing gates would be ideal.
I'm just opening your minds to ideas. You tell me what you want to use it for.
Oh, price-wise, I think replacing the stationary decoders, if we can use those for switches, it would definitely be cheaper.
Do they have the torque, or have they been tried to make sure?
Pardon me?
Do they have the torque? Have they been tried to make sure they can? I didn't see that one.
You can grab onto it and see.
Because I look at that, if you could run 5 or 6 switches for $20 compared to 50,
But
you're saving $30 a unit.
Yeah,
Well, plus
How
you
would
also
you
have to
throw
buy
a
the switch
switch?
motors.
yeah, that would be the
No, you could throw
difficult
the
part at
switch
the
with the
moment.
servo.
Oh, I know that, but.
Yeah,
what I'm
but
saying is
telling the
just prices.
telling the servos when to make the change, that would be difficult because with the decoders we have now, you can do it through your handheld.
So what would-
Until we came up with a solution, you wouldn't be able to do it with this type of scheme.
See, if we mounted that under the layout, you would have to have something that would still go like this to move the switch, right? So that would basically give you the back and forth motion, and then we'd have to mount it either through that hole of the switch or put it to the side or something.
But it'd be very much like a tortoise, because you don't have to mount it this way. I mean, the mount on that is on the side, so you can tilt sideways. And
Well, I was
now
thinking-
you have the same swing as a
Yeah,
tortoise.
simple wise, you could just use it like that, just mount it into the layout, put a little bar on it and pull this way, that way.
You gotta remember one
And
thing,
then put a
though,
cover
the
over
tortoise switch motor works on a different
I understand. Premise.
mode than this would. The tortoise switch intentionally goes to its limit and then it just stalls there.
Right.
So that provides continuous torque to hold the points in position, but it also draws continuous power.
Well, yeah, on this case, though, from what you're saying, if I can program the swing, I can create that pressure which you want to keep the points closed by simply having it go a couple of degrees past.
Yeah, you'd
And we use
in
the
that
spring motion.
in that type of situation, you would probably want a slightly flexible connection from the servo to the throw bar
Right.
to allow for some over travel to provide pressure. Of course, that would be less necessary with the Picos than
Well,
with others, but
Well, that was another thing, somebody asked something about the power, because I can tell you from experience, with a tortoise machine, you have to pop that spring out of the Pico.
I've heard that. So I
And
haven't,
especially if you've got a long throw, which I do,
yeah,
you have to pop that spring out, and, which is no big deal, but of course, if you don't want to use it as a snap switch again.
Well, you know, the other thing the best thing to do with a tortoise machine, take the throw wire they give you
And put it
Throw it.
and throw it in the barrel.
I agree with you, I've had to make longer ones, and you get pretty good at bending the little, what is it, 70-degree angle?
Yeah, yeah,
I know Ed uses that piano wire.
yeah.
He throws away that stuff, and because we don't pop the switches out of pop the spring out of his switches when we put them in his.
I'm too-
No, if you use a stiffer piano wire, you
Yeah,
don't
it
have
works
to.
fine.
Yeah.
My question for you, Jack, is,
Things work too.
the problem I see, and I'm not, you guys are way above my head as far as, you know, what you're talking about. The problem is we cannot control this servo with this unit as it sits now from our controllers.
that is correct.
Right.
Now, I guess the problem is to get that interface so that we can do that.
That's something I gotta look into. In fact, I wasn't even aware of it until Doug mentioned it earlier tonight, which was one positive thing out of this little tech talk.
But if you're controlling from a front fascia board, like which track of the yard you want to set.
Well,
Yeah,
that's
then
true,
you're- then
yeah,
you're
we're gonna
fine.
bypass our.
You can have push buttons or toggle switches or anything like that
Yeah.
to do it manually.
Well, that might be, in all honesty, I could say from running upstairs, it might be a better solution Because sometimes if you don't run up there often enough, you forget the number of the damn switch. So, you know, if I can push a button, you know, it's a simpler method.
Have it voice activated.
Keep the young
How much
kids out.
memory is in this Arduino?
I think it's 64K, I'm not certain.
I think it's 128.
128?
It's pretty big. So.
Is that flash?
Yeah.
Yeah. So
That is big.
What do they use on the RCs, on the airplanes? I mean, I know,
I don't know.
yeah, they use a servo.
Yeah,
To drive it?
Yeah, what are they using to drive?
Very
it?
similar.
Oh, that's-
Another little mic. Sorry.
Yeah, some are analog, the newer ones are digital.
Yeah.
Again, you know, a lot of them, it's the torque rating depending on the size of the airplane, the size of the control surface.
The price of their controllers, now granted, it's a whole totally different separate operation, but they come way down.
Oh, way down, way down, yeah. Yeah, they're less now than they were. I started flying RC when I was 13 years old. In a decent 4-channel system was $300. And now you can buy a 8-channel system with all the whistles and bells for $225.
Yeah, about 38 years ago, I bought one for about $280.
Yeah,
I'm old
yeah.
and blue,
probably have
I was happy with
Yeah.
one
10
channel.
times the range.
I had
Probably.
8
Oh.
channels.
Well, they
They're all computer radios now, and you know, you've got the computer, you have endpoint adjustment, servo reversing, exponential, dual rates, but that's all done through the transmitter and sending the signal to the receiver. But you know, when you mentioned you can have a T-arm, because a lot of the giant scale guys use the big servos and they use a pull-pull. Rather than use a push rod, they have a control horn on each side of the control surface. And when
Yeah,
it
'cause some of
goes
the-
in one direction, it pulls,
Some of
the
the,
other direction it pulls, so you don't get any flutter. Yeah.
some of the attachment points that they have with this one here have dual,
Right, yeah,
so that you get a push.
Yeah,
right.
Use a horn. I mean,
Yeah,
yeah.
so you could do your crossover.
yeah.
I hate you guys with your goddamn phones. You show me pictures all the time.
Well, I could say 1,000 words to you or show you a picture.
It cuts down on a lot of talking, doesn't it?
You understand the words, you understand the picture.
These are the ones that Jack was talking about coming
I think
up?
so, just not, yeah.
Yeah.
It's just a different cranks.
Yeah,
Oh, they just put, okay, this is,
Yeah, all that,
That's a
that's,
servo kit and it comes with a different crank.
yeah.
right. The different lengths,
You
obviously.
might get a T, you got an L.
You get a T, they got some
Yeah,
some circles,
straight, full
Yeah.
cross,
it's like a circle, and you can put it anywhere you want on the circle.
Oh, that's cool.
So are these generally all 5-volt servos, or
Yeah, please.
do they make them in different, like
Is that,
12-volt? for their
No,
size?
no, I think most of the model airplane servos,
yeah,
I think, are
that's,
3.5
in fact, that
volts.
looks almost like what's right here.
Yeah, it's pretty simple. That is the Tower Pro.
It just
Yeah,
got bigger,
yeah.
the motors gets a little
It's the
bigger.
stuff that comes with it.
Yeah, I've got this other stuff too, back at the house. I just put on the one.
For that is there.
Otherwise, without an arm on it, it doesn't
Doesn't look.
It does
show on the
But even some of those servos,
This is just a DC motor.
they've got like lifting wheels and
How
stuff.
would
Yeah.
you start applying
In
this,
fact,
you know, to the layout upstairs?
Thinking of what you want to do.
You'd expect it to have multi-turns.
First thing you have to do is to able to describe what you want to happen.
Yeah.
Once you can write down and describe what you want to happen, then you can start figuring out how to go about
You can
doing it.
pull having to heavy stuff
But if we can
without
get some
having a
people in
very
the club
large.
that have the time and the interest,
Yeah.
I have the interest, just not the time right now.
Yeah,
The knowledge.
But to work on the local net, no, you see, the knowledge, it really comes down to the time and reading. It's not that hard. It's different, but don't be intimidated by it because, you know, with all these things, anything electronic nowadays, there's a learning curve you have to get over.
Oh, yeah.
And it's a point of frustration. And I would say have the patience to drill through it. And now I know my brain was programmed differently than yours when you were a kid because it's different generation and stuff. And so
But
I grew up
everybody thinks differently
and
too.
my kids can live in a 3D virtual environment and find their way around it all day long. I can't.
Yeah.
But that's the way their brains are programmed.
I have trouble doing the JMRIC program on my engine on the track. Somebody really gotta teach me like a little kid one by one. But the electronics and this stuff, I understand. I've been doing it for a while, so I understand that part of it. I'm an idiot when it comes to that.
It's really not that difficult, once you understand what the things are doing.
Yeah.
A lot of people have the idea that you're programming the decoder. You're really not. It's into the decoder so it knows how you want things to happen.
Right.
You put in delay so it starts up and slows down slower than it normally would. You put in an address so it knows what to respond to. You set up how you want the lights to work,
Yeah.
how you want the horn to work.
That's what I see.
All that sort of stuff. You're not reprogramming the computer. Those points have already been put in a table for you to be able to change as you desire.
Yeah. You gotta be able to just write down what you want to happen, how you want it to happen, and in what order. And then you can take the little pieces and build it one at a time.
A lot of those things are essentially independent of one another, so that you can try this, that, and the other thing, see how it works, and then go on to the next thing. Probably the first thing that most people would want to do is, well, the address obviously, but your start point, your start voltage, to get yourself a good smooth start. Some have a kickstart provision. The big thing is a lot of the decoders are not identical. They have different characteristics. This is a reflection of the thoughts and ideas of the company that put them together. There's certain areas where they're all the same. In most cases, where they're using a CV, they're using the CV just like every other manufacturer does. And it'll usually behave pretty close to the way the others do.
Why don't you leave it there?
Yeah. But there's a lot of CVs that are left to the manufacturer's discretion as to what he wants to use them for and how he wants to use them in doing that. And that's what drives a lot of people nuts. That's also why it's almost impossible for somebody to come in and give you a quick answer to why your engine doesn't work the way you want it to. I know I can't do it without knowing what kind of decoder you got in there. How do you have these programmed? Things like that. Where's your manual? I think I've asked that question of a number of people.
What, did you read that manual? Is the bigger question.
Why?
Why would anybody read
Jack,
it?
I'm looking at this article you're passing around, and I just read the guy who wrote it. And it kind of, it would scare a lot of people off. It says, William Mitchell is an adventurous hobbyist. Adventurous hobbyist. And he thinks real outside that envelope, maybe.
Has anybody been down to the Choo Choo Barn down in Strasburg?
I have.
A long time ago.
Would they make use of the servos down there?
Yeah, they probably did, because there's a lot of movement, motion.
Yeah, okay. Because I was, because I was wondering, there's one display of Amish people that you build in a barn, and there's guys sawing wood and they're hammering and stuff like that. They are controlled by servos.
That more than likely,
Okay.
yeah.
I actually, to expand the thinking here a little bit, because this opens up a lot more opportunity, and so let me just, and I haven't used servos, that's why I came here tonight.
Neither have I.
Because Jack was talking about it, it's like, I'll get a chance to learn something, but,
I'm throwing
At the
ideas
Choo Choo
out in the
Barn.
fertile fields.
at the Choo Choo Barn, most of the motion that is at the it was probably 8 years ago when I was there, so they may have upgraded, I'm sure they've upgraded. But the motion that's there is rather cyclical. And for example, a motion going back and forth, as John mentioned, the Amish village there where they're doing a barn raising or whatever. There's a gentleman sawing,
Yeah.
that's cyclical. And most of us know that you can take rotary and make it cyclical and
Sure.
vice versa, right?
Yeah.
With just a crankshaft and a
And
connecting
or-
rod,
and
that
Or
type of stuff,
cyclical,
right?
make it rotary.
Right, and rotary. But what you can't do with a motor, and most of those things out there I think are controlled with a motor, maybe on a gearbox to slow it down.
Yeah.
And then a linkage and a crankshaft to make these types of motions, linear motion from rotary motion and vice versa. But what you can't, or what you don't see down there is a guy doing this, stopping here, maybe going a little more like this.
Because as the thing goes around, it speeds up, and when it gets over here, it slows down while the arm's doing
Well,
this,
the arm
and then
is
it
right,
speeds up
that
and slows
linear
down.
motion
So
stops
it-
for a
So it makes
very
it look like the
slight
guy's
time.
doing this instead of going steady. So
Right.
there are a lot of things you can do with changing that circular motion to
what-
straight motion.
What Doug is saying is you're really opening up a whole new can of, not worms necessarily, but you're opening up a whole, you
I know.
realm of
It's a
possibilities
basket of
now.
opportunities.
And I'm looking at this little article you passed around, and the guy threw in a switch motor, and he's just chiseling a little hole in the foam, and then holding it with epoxy. I mean,
Yep.
how easy can you get? None of this fishing a rod through the bottom of your, you know, and swearing a lot as you do it. It makes the,
Or cutting a big hole in the phone.
that's right.
Pico switch motor in.
You and I know that, don't we?
Don't a lot of our switch motors just have a little pin sticking up that we take and we pull to switch them?
That's what we have now, yeah.
Yeah, I'll put the pin right onto there and the motor's all set up. You just gotta program what the stroke is.
A lot of these things, you know, where we have turnouts, they're hard to get to, and we wouldn't really want to directly mount them there. But if you get, I'll say piano wire, correct me, there's probably something else, but you can get thin piano wire and you put it in a Teflon tube.
Right.
It's a small Teflon tube that's designed for the wire to slide right into it. And now you've got an actuator that you can position several feet away.
And it
And then
doesn't
all you
have
gotta
to
do
be
is put a,
straight.
at one end you put a hook,
Right.
you know, that to operate the turnout. At the other end, wherever it needs to be, you put the servo, and then you tune the stroke of the servo to match what you need,
And it
whatever.
doesn't have to be straight.
And yeah, exactly. That way, from a serviceability standpoint, or if that's maybe maintenance or whatever,
That's good.
we're not
Operation.
killing ourselves to get to some of these turnouts. And we're talking right now where some of them are, they're difficult to get to, and we're probably going to want to make them even worse. So,
Some of the ones on the.
That's how the, if you've ever installed a tortoise machine, a remote location, that's in model airplanes, it's not, they call it NIROD, and it's an inner and outer,
okay, yeah.
and you can squirt it around, and there's no, well, it isn't really any different than the throttle cable on a lawnmower. The metal-
Exactly.
the metal
Bicycles,
jacket
your
with
shift
the
on bicycles, all that
shifters and
stuff.
bicycles, yeah.
Well, the one in the, it's spring returns.
It takes
Yeah,
You
away-
can't push a rope.
I just put a, I
This
put-
is true.
Yeah, the rod's solid, so you
Yeah.
can put.
It's solid, yeah.
Yeah.
I laid down a nice drawing on my module, and all of a sudden I have to move a switch, because below the switch is,
A 2x4.
yeah, 2x4. There's no way you can get a tortoise or anything underneath there. But now if I could come at it with a flexible tube, basically, it would work. Yeah, well, that's cool.
That might even be smart, I mean,
It'd make
with
it all.
the solenoid valves that we, excuse me, the magnetic solenoids that we used to have. Those are the actuators that we use for the Picos now.
Right.
Those directly mount, and we're stuck with that.
Yes.
And you can put them somewhere where they're out of the way, hide the cable down underneath something,
Yeah.
and
I like
put a
what
building
you-
over it if you want.
I like what you said though, Doug, is it's a serviceability, as you say, if that's such a word, because Don had the problem, and I threw a bunch of Pico switch machines away.
Thank you.
Because once
Okay.
you bury them up there, if they drop out of sight, they're a pain in the
We'll see you, Mark.
keister. Take care, Mark.
See you, Mark.
I'm gonna go take a
They're a
shower.
pain in the bunskies to rectify the problem.
So this is limited to our imagination,
It's going
as
to
Jack,
add,
as Jack mentioned, so.
Yeah, no, it's,
it's going to add a lot more motion, you know, to
it
the
gives you
layout.
another thing to think
Other
about
than
when
just
you have a
trains.
problem to solve. Another solution.
Different type of hammer.
Yeah, that's exactly right, different.
Different type of what?
Hammer.
Hammer.
Well, the only problem I see is that we have to be able to control these things, either by,
Well, that's an area we've got to deal with, and Doug has probably brought up a potential solution for that. Because that's an area I was sort of concerned with. I wasn't there yet, so it really wasn't an important thing. But ultimately, you want to be able to talk to this thing through LocalNet. They've already got shields for them that'll take SD cards and Ethernet connections, and there's all sorts of wild stuff.
I'm pretty sure an aux box would be able to control.
George, how would an aux box work?
How does it work? It's just consider it as a DCC addressable set of relays.
I'm yanking you chain, that's all.
It's DCC addressable, it's not LocoNet addressable, right?
I don't know in
It's
detail. I
basically a
gotta find that
stationary
out, too.
decoder.
It's a stationary decoder, right?
Yeah, okay.
With 12 or 8 outputs, depending on there's 2 different kinds, a heavy duty and a lighter duty.
Yeah,
And each one of those outputs could go to one of these.
yeah. So you could, a Digitrax mobile decoder, a mobile decoder and a stationary decoder are electronically the same thing.
Yeah,
But we could take, I think the cheapest stationary decoder, the cheapest decoder that's out there that I've seen is like an NCE, I don't forget the numbers, but they've got 3 outputs on them. Front light, back light, and a secondary light.
there's the TLs,
There's probably more,
Fun-
but like
function-
$15 or something like that.
function decoders.
Well, it has a motor drive too,
Oh, it does, okay.
but you could take that and drive 3 separate inputs to this.
but they have chips.
For
so they
$15 on top of $15 for this, so
Mhm.
for $30 you get a
Mhm.
3-channel, I don't know, whatever, so.
They do make chips, I understand, though, that don't have a motor drive with them at all, which you don't need. Is that
Yeah.
correct?
Right, that's a stationary decoder.
T-
Yeah, well,
TCS.
You're right, but they have chips, I know, for,
TCS and Digitrax do it, I'm sure the other ones do it as
yeah,
well.
they use them for lighting,
Mhm.
cars and stuff like that, where they
Yep.
don't need a motor drive. Would they probably be cheaper? Maybe,
If you can load the LocoNet library into it,
so.
That'd be the way to go.
LocoNet, then you can tie it to LocoNet. If you don't want to tie it to LocoNet, I'm sure it'll take there's a DCC interface for it as well. And all it is free software you put on it, so there's no money associated with it, and it's just putting the right software in there.
LocoNet access from JMRI.
There's a whole Arduino development group. It's an open community, share all your free stuff.
Doug, do you need a hardware interface to go from the 12 to 16 volts down to the TTL that this needs?
Right,
And it's just a schematic that's already out there, and just go build this?
maybe. I'll bet it's commercially available. I'm betting. The LocoNet Shield is commercially available, which converts the LocoNet and gives you all the interfaces for that down to TTL to interface to this. TTL is a 5-volt logic signal.
If somebody wants to build a module here in the club, and I'm sure we're gonna be building modules to replace other things, and that person comes up with an idea as to, they want movement on their module, can there be a group of people in this club that you can go to say, how can we do this? Or how can I do it? or what do I need? Because I
I'm
can
sure
think-
there'd be a bunch of people that like to discuss it. It'd be an
Okay.
interesting
that-
challenge.
to have a, not as much as another committee, people don't like that word, but you need a
Committee,
group.
yeah.
Maybe you just need a
Special
bunch
interest
of
group.
good friends that belong to the train club that
Special
wanna give you a
interest
hand and help you out, and not be
Because-
anybody.
I would like to build a module, then I said, okay, I'd like to have this move. Now, beyond that, I don't have a clue, other than get in underneath the module myself and pull the wires.
John, you're like me in that respect,
And-
because I've got something I want to move, and I don't know how to make it
Well,
move
yeah.
at this point.
And that's what I'm saying, does this club need a dedicated group of people that you can go to?
I don't think you need.
Or,
I don't think we
mailing
really
list.
need a dedicated group. Like, we got enough people here that are interested in trying to help. All we gotta do is have enough gonads to say, hey, guys, I'm trying to do something. Does anybody wanna give me a hand? This is what I'm trying to do.
okay.
Yeah, if people wanna get going with this, like Jack went off and bought this, I think you got, I'm not sure where I learned about it, but I picked up an Arduino board and started playing with it briefly, and then I handed it over to Jason, and he took
Yeah.
over on it.
I saw-
I haven't got it back yet. I gotta buy another
I
one.
saw what you had, and then I started looking around at it, and I said, that was
Maybe-
kind of interesting.
Maybe if you.
One of these days, I built up a board similar in concept to this, using 8051 style components.
Mm.
But this was years
I was
ago.
gonna say, that was a wee one.
Yes. I'll bring that in some night. I was thinking of bringing it in tonight, but I thought that would be distracting from the, but I bought that in. A lot of the technology on that is, I won't say ancient history, but nobody uses ultraviolet erasable proms anymore.
That was a college sophomore class.
That was a 101 class.
That was over 20 years ago, so yeah,
Yeah, the people like me who weren't
25
laughing
years ago.
don't have a clue as to what you're talking about, so.
There's a little window, and if you
Yep,
left them open accidentally,
your program is gone.
You know, it's interesting what we're talking about.
It took
tonight.
quite a while to do that, though.
yeah.
I commented, guys, I saw a guy this weekend that has a 1946 model railroader, and he said, geez, and that's back when we had to build all of our locomotives and build our this and build our that. I said, that's true. I said, but now we spend our time scratching our head trying to figure out what the electronics is or is not doing.
Just like your auto mechanic, Mel.
Huh?
Your auto mechanic has the same problem.
Oh, I understand that. I agree. And this is, I said, you know, it's a totally different set of problems that we deal with on certainly different levels. And, no, I won't say I'm sorry. I'm old enough to remember, as Fred was saying, when we had to put paper on the sides for the box cars and stuff like that, and everything was,
Those
I
kids
don't
go
wanna
cheap
go
on
back
eBay.
there. I don't wanna go back there. I'd like to go here, all right?
This can also control lights too.
Sure.
Yeah,
So all your street lights can come on in your town.
and
Oh,
then
you're talking
They
about
can, they could dim on and off.
There you go, Paul.
Well, you're talking about the
All those
little,
lights you have upstairs.
Processor.
the
They
process.
don't have to
You
stay
could
there.
also have a light dependent resistor on one of the inputs, so it did it
Hold on.
automatically.
Huh?
No changes. Anybody
No
want to change it?
changes.
Anybody want to change it, they can go change it.
at the MIT layout, they have a commercial building that has lights in the windows and they play Tetris with it.
Yes, I've seen that. Yes, I
You know,
have.
I was thinking, you had a hotel, you could have the room lights that go on for a
Yeah.
little bit, and then another one go on, and this one goes off, and that one
There's
goes on.
there's
for a
all
while.
sorts of things that could be
Yeah.
done. It's, the limits your imagination, basically.
Could you get the lights to, like, you know how when they first come on, the street lights, they flicker?
Yeah,
Would you be able to do that?
yeah.
Sure.
The hard part is finding what's really random, what looks random, and what really is.
You could do that too, though. You can turn your lights on upstairs,
Libraries, there's
a
randomized.
different
You can
sequence.
turn them on
It's
and
not
off.
bad. You
Yeah.
get pulses that are so narrow, it doesn't even.
No, I mean, we all know that, especially when you get down to any show you go to,
With an LED.
if you can show some animation or some movement other than just a train running on the
I
track,
was thinking LED.
people
because
just
it's
go
supposed
crazy.
to-
It's still
Well, that's
not
why
big because you can have.
If you ever get down to Strasbourg, make sure you go,
One millisecond.
I've seen
I've
this
been
church.
there.
See it.
Okay.
Yep, been there.
You know what I'm talking
Yeah, we
about
can get
then.
the bungee jump with the judges to jump.
but there's
In
gonna be
fact,
a-
Make some people
Bring 'em
want
back up.
soft
Minimum
materials,
length.
so
You can go through that whole place and probably ignore the trains or
I
whatever.
think I'm about wound out.
Thank you very much, Jack.
Thank you,
Thank you
Jack.
for recording this.